Hello everybody, welcome back and let's get started. By the way, nowadays it's getting a bit harder for me to even go live on a daily basis, but never mind, whenever it's possible for me I just simply go live and start working on the things. That does not mean that I'm not working or learning the things. I am, but the thing is that because of some reasons it's just not really possible to go live. That's the only thing. By the way, without any further delay, I hope I'm audible. That's the okay. There's gonna be some background noise. I cannot really do anything. It's too hot, and I don't wanna just simply work in the room where there's a lot of heat. Hence, the fan is on right now. By the way, what are we gonna be doing right now? We are just simply gonna be working on this mm, DevOps part really quickly. So what we are gonna do here that we have all the steps already written. So we will be just simply following those steps. We have already talked about cluster pods, replica set deployment, and also we are not gonna be talking about them. Right now, what our main focus is going to be, that is just simply creating a backend manifest, and most of the things we already have, so we don't really need to even worry about them. Oops, everything else below. Okay, that's fine. So it actually starts from here, right? Not even from here, from here. So let's get started without any further delay. I even had the project ready, so let me quit these two windows and spin up the project first of all. It's gonna be pretty simple. That was inside learning, and this was a to-do deployment. So we almost worked on this particular project. We have a proper backend ready, we have a front end ready. We even built the images, if I'm not wrong. We'll see exactly how much is covered and how much is remaining, and on the basis of that thing we'll just simply be going ahead. So of course, before doing anything else over here, I need to check the images. So docker desktop is start. It will be just simply starting my docker, and once it is started, after that docker images. Now I have these two images right now. I have the backend image, I have the front end image. For the database, I'm using the PostgreSQL over here. Ultimately, yeah, PostgreSQL. So I have to make sure that I have the database running. And what is the URL of that particular database? Let me see. So inside backend, I have my Prisma. Ultimately, I need to know about this. The database URL is the local one. So that's the one that's being used right now. Hence, docker start PostgreSDB. So it has also started. Okay, what is the next thing that I have to do? Let's see. I was mainly working on the backends manifest actually. And what all have I done here? I created the namespace for the backend. So to-do's backend, that's fine. This is the namespace, and to-do's backend, that's not bad either. It could have been to-do's backend namespace. Too bad. Backend namespace. To-do's backend. To-do's backend. Then I will have different namespaces. That's gonna be bad. So to-do's namespace. To-do's NS. Because the namespace should be the same for all. The namespace should be the same for backend, for the database, and for the front end. Only one namespace should be for the entire team over here. Should it be like that? No, let it be like this only. So to-do's backend namespace, I'm just simply gonna be calling it like this. This is just the namespace NS, and the deployment we have over here, and then to-do's backend deployment we have, and the namespace is gonna be to-do's backend NS, of course. And spec we want two replicas of what? Two replicas of the backend. So backend will have two replicas, and backend is gonna run this particular backend. So load balancer will be balancing the load. Sort of. The load will be balanced among these two, between these two replicas. So that's fine. Selector is the match labels backend. This should ideally be to-do's backend or backend, that is also fine. Not really big problem. And then app backend, that is okay. Template. The thing is that this is the label that it has. If it has this label, then if others have the same label, that's gonna be problematic. Hence, I'm gonna be calling it to-do's backend, so that I know like which kind of pod this is. and then we have the images, to-do's backend. This is to-do's backend. That's okay, this is just the name, not really big problem. Image, this is the image that we have. Ports, these are the ports that are being used. Apart from this particular thing, I even need to have the service over here. So just below this, if I'm not wrong, I need to have the service too. Again, I will be getting the reference from here. No need to remember even anything for no reason. Okay. By the way, as for this configuration, as you keep writing, you will automatically remember that. So we have done this much thing. Apart from this particular thing, we have to just simply create a service. Inside service, we have the API version, we have the kind, we have the metadata. Backend service, we are even giving it the namespace. It has the selector, it has the ports, ports in the sense it will have the protocol, it will have the port, it will have the target port and the type. So let's see. So first of all, what do we want to create? We want to create a service right now. Just below that, what is the API version of that particular service? That's v1, so that's fine as well. Metadata, metadata. What is the metadata over here? Metadata will have name, of course it will have the name, and this is gonna be to-do's backend, to-do backend. Let me name it to-do's backend first of all everywhere, so that naming is not wrong. Coming back to this one, this is gonna be to-do's backend service. What is the name of the service over here? Backend service, to-do's backend service. Okay. As for the namespace, it will have the same namespace. Ultimately, to-do's backend NS stands for the namespace. We will have some spec over here. Inside this spec, it will have a selector. Selector is gonna be only one. Match labels on the basis of app and to-do's backend. This label, it will be just simply selecting. I hope the label is the same. Label is to-do's backend, right? To-do's backend is the label, that's fine. And apart from this particular thing, it will have ports. When it comes to the ports, it will have protocol first of all. Protocol is gonna be TCP over here. And as for the name, that's gonna be name of this to-do's. Nope, not name actually. It should just have the port. Port should be on which port will this service be running. That's interesting. Usually the services run on port 80. So I should ideally be running it on port 80 target. Let's see how it's gonna be going on. Target port is actually gonna be 3000 if I'm not wrong. My backend is actually running on port 3000, isn't it? 4000 actually. So target port is gonna be 4000 and type is actually gonna be, now what is the type? That's the cluster IP, right? So cluster IP. So this much we've done over here. As for this port number over here, 3000. So cluster IP can actually run on port 3000, but the thing is that if it is actually running on port 3000, I will have to send a request to port 3000. If it is running on port 80, so I don't need to mention the port over here. So let me see, I will be trying both in the sense, try port 80 as well. So this is gonna be a to-do over here. Overall things are ready. The next thing is the front end stuff. Again, this time I'm gonna be just simply copy and paste the stuff here. Copy, and of course I have to paste here. I'll have to change many things, but ultimately even on the front end side, I will have to create the namespace front end team. I will have to create the deployment, metadata, front end replicas. Front end is gonna be only one. And front end will be exposed. That simply means it's gonna be using load balance. Sorry, not. It is using cluster IP because I'm gonna be using Ingress. So I need to have only one front end because front end will not have a lot of load. Ultimately, makes sense. You can have multiple front ends as well, and the load is gonna be balanced among them. But okay, for now we are gonna be going with this way only. And as for this port, it is also running on port 3000. This is a service. This service also runs on port 3000. So all the services, they run on port 3000 by default. And then just a minute. So if I'm not wrong, so whenever I'm getting the address, I'll have to specify this port 3000 over here, right? because they are running on port 3000. If I were running on 80, then that would not be the case, but okay, I'll see that. Okay, let's fix this, the front end part. So this is gonna be to do front end namespace. That's fine, to do front end namespace. Should I be giving them separate namespaces or the same namespace? That's interesting. If they have separate namespaces, because when it comes to these two that I have, so it has backend team here, name as a, it doesn't really have any, okay, it does have a namespace. So it has backend team namespace, and the front end one has front end team namespace. So they do have different namespaces. So my front end has different, backend has different, and a database that will have different namespace. So how will I connect them? API version apps metadata DB. This is gonna be wrong. Why this is gonna be wrong? Because they have separate namespaces. Even if this is gonna be the database will be using default namespace, how will the default namespace be able to access the values from another namespaces? So they need to be in the same namespace, right? So ultimately things are not quite right here, if I'm not wrong. I'll see that anyway. And then we have this config map we created. Once the config map is created, what we are doing from here, that listen port 80. So okay, on port 80 I will be getting the, this is the config map. Load balancer will send the request on port 80. That's fine. KTS backend code in the code.site. I will have to just simply redirect it back to HTTP backend service backend team SVC cluster. Yeah, this is the 3000 port that I'm mentioning here, because my service is actually running on port 3000, hence I'm mentioning it separately here. And as for making the requests, so backend service, this is the name of the service. First of all, this is the name of the namespace, svc cluster.local. That makes sense. And this whole thing will just simply give me the sort of the IP address, address of that particular node. So this is how it's gonna be going on, and remaining things are fine. We can just simply go through that. That simply means even if I want to use port 80, we can use that. I will even show that to you. And then we are gonna be creating ultimately a pod that will be, the name will be ingress, and that will have the default namespace. So the best way could be giving them the same namespace. So that might be bad. Let me ask AI regarding this thing. I hope that's a good network. Let me see what it says. Should I give them all the services different namespaces, or they should have the same namespace? Alrighty, so I'm working on Q1, it is deployment part, and in this particular case, I have my front end, back end, and a database. I want to deploy all three of them. Now the question is, should I give a back end, front end, and database separate namespaces respectively, or I should be giving them the same namespace? The thing is that if I'm giving them the different namespaces, so how will my backend be able to, how will my backend be able to talk to the database? Because ultimately they will be on the different namespaces. So won't that be problematic? I even have the code written. It's not like I don't have the written code. I did it a while back in the sense many days back. So the overall process that we have to go through to get this particular thing done, that was where not here, of course, probably HPA. This is the overall thing. So we have HP, a horizontal pod, auto scaling, not auto scaling, whatever. So here if I go to the sample app section, inside the sample app section I have backend team. Backend team has the backend team namespace. Ignore this, I will be talking about them. Then I have the deployment. Even deployment has the backend team. That is what I sorry, not deployment, load generated had the same backend team name. So ultimately it doesn't matter which thing you talk about, they have the same namespaces. So if they want to talk to each other, they should be sort of, let's see, having the same. No, actually, even if they do not have the same namespace, you can get the IP address of that, right? And you can talk to that. Let's see what AI says here. Should you use same namespace or different? The common practice recommended put a front-end, back-end and database in the same namespace. So it is asking me to put front-end, back-end and database in the same namespace. Why? They belong to one application, easier service discovery, easier management, cube cutter logs, monitoring, less complexity. When do people use different namespaces? Use separate namespaces when you want isolation, like dev namespace, staging namespace, prod namespace, team or micro isolation, so payments, all these things, security. Your concern if different namespaces, how will backend talk to good thinking, but Kubernetes handles this easily. Even if they are in different namespaces, communication works via DNS. That's sort of right, service name, them namespace and something like this. So how communication works, so this way you will be able to talk to that, so you don't really need to worry about it. So example, they may be in diff separate namespaces, but backend wants to connect, use this namespace, that's right. Ultimately this host name. Namespace versus cross namespace. So backend connects to connects like DB service and then DB service database for DNS. For your case, front end, backend in this best approach, namespace, my app. Keep all three of them together. Ultimately, this is how it's gonna be going on. We can keep all three of them together. We can keep them separate as well. Let's keep them together for now. I mean, doesn't really matter much. I can actually call them to-do app namespace. That would be better. And later, if I'm working on this, well, I'm actually getting a call. That's strange. Why should call? Thankfully, my data it didn't get disconnected. Just give me a moment. I'll be right back. Getting a call, so I'll have to know the reason behind that. And just give me 1 minute. I'll be back. Alrighty, just a sec. Let's get going. Alrighty, so we were here, and what we decided that it's better to give them the same namespace. So that's what I'm gonna be doing here. So this is the front end section, to-do app namespace. That's the name here, and I would have named it to-do app only. That doesn't really matter. But as for this namespace, this should be this one, and that's it. Nothing else. Okay, even this service has the namespace. You can give them the different namespaces as well. That doesn't really matter. But okay, let's give them the same namespace, as we don't have many services here. So I mean, we don't have many things running. So it's okay. Later we will be giving them the separate namespace as well. So backend service, this thing is done. Hopefully there's nothing wrong here. Alrighty, this seems to be okay. Same thing I need to do here. So ultimately, wherever I'm using this particular namespace, I'm gonna be replacing it with this, and this is how it's gonna be going on. So this particular thing is done as well. So backend is ready, front end is ready, not ready. I just want only one replica of the front end. I can have multiple one, but okay, one is needed here. Deployment app to-do front end. Deployment to-do app. Okay, replicas this to-do backend. the label should be to do's front end. Again, there's gonna be only one front end, but ultimately a replica is going to be there, so that's fine. Name is gonna be to do's front end, and image is gonna be to do's front end. We may have to change the label over here if we make some changes. As for the front end, this is gonna be running on port 3000. Service to do's front end service to do's name. This app label is gonna be of course front end. We have done this TCP. It's by default we are making it run on port 3000. Completely up to us. Later we are gonna be making it run on 3000 as well. Port 80 as well. So I'm just simply saying that the service is gonna be running on port 80. That is not mandatory actually. You can run it on port 80 or any port for that sake, and then you have to just simply redirect it to this one. There is a thing. Here I'm gonna be creating my controller, my ingress controller manually. That simply means I'm gonna be running Nginx manually, and that Nginx will be responsible for forwarding the things and all. This is what I'm doing here, and you can even create you can just directly use ingress controller by just simply integrating that. In that case, even over there you just get the option to forward. Let me see. So over here I'm running it on port 80. That's fine. Even this is also a service, but here I'm running it on port 80. That simply means the ingress controller is forwarding the request to port 80. So let me see where I have the ingress controller here. Sample app, I should have it somewhere here. Ingress controller, a load manifest. Okay, this is not what I want to talk about. The ingress controller is responsible for, okay, so don't I have the ingress controller here? Links are not clustered. Mail used for creating that. Okay, not really big problem. Policy, not really needed. Then we have service account. Ignore this. I got it from the AI, of course. Well, I will be explaining exactly what they do. R2 scaler we have over here. I mean, especially with Amazon, you have to configure a lot of things. Metric server, HPA, horizontal port scaling. Interesting. Where do I have ingress? Turns out that I'm not using ingress over here. So if I'm not using ingress, yeah, ultimately what am I doing? That using this load balancer, the load balancer, another pod I'm creating ultimately inside that. So there's another pod that is just simply responsible for sending the request to the cluster, another app. So like there are two things running. There's my backend running. There's another load balancer running. Not load balancer, load generator running. That load generator keeps sending the request to my backend, because both of them, all the things are running inside the same cluster. Hence they can just simply talk to each other without even a load balancer. Hence we don't really need to use ingress over here, but I must have used ingress somewhere else. So let me see that if I can find. So this is where I used ingress controller. So probably this one. Yeah, so we want ingress metadata is gonna be this, and over here we have the rules. So ingress app coding the code.site, this is where we will be getting the request, and then path is gonna be /backend. Again, you can come on here, what have I done? You can use ingress controller two ways in the sense you can actually redirect the request based on the subdomain. Like here, this is the not subdomain, based on the routes. So you can first of all redirect the request like this. So if the route is /backend, so the request will go to backend service, and on port 80. So it could be port 80, could be port 3000, depends exactly which port you are running your service on. And if that has the front end route, it will be going here. The another thing is that you can redirect the request based on the different subdomains in the sense the subdomain itself can be different. Backend subdomain will have the backend subdomain name, and similarly front end domain will have front end subdomain name. I mean, this is how you can even do that. So there are two ways ultimately what I mean. So you can even use this. As for the steps, you can simply find it where the steps build arguments while building the Docker image. Let me see if I have the steps over here. What am I doing here? Arg next to public backend URL did this. This is just nothing but an argument. So if you are passing an argument while creating the image, you can use this. Why do we need to pass an argument over here? This is, I think, just for the learning purpose, if I'm not wrong. So ultimately, what am I doing? That I'm just simply creating the image, and that image is of what? That image is of Next.js. That Next.js needs the next public backend URL while building the image. Is that so? I don't think so. I mean, the image can directly be built, but if you in case need the backend URL, definitely you can pass it over here using as an argument. That is fine. And here, build argument, you can just simply pass it like this. Just a sec. Okay, whatever this is right. But the question is that why am I passing it? It is backend code in the code.site. Anyway, we'll see. Because this argument that I'm actually passing over here, while building the image, I don't think this is required. The image can be built directly without the argument as well, but let's see what's gonna be happening. As for this thing, we don't really need a return form. This is this is actually the deployment. I mean, if you wanna use a ingress controller, the ingress real controller I'm talking about, because in our case we are creating it on our own. You will have to apply this particular deployment, then your ingress controller will be ready. Then once this is applied, then you have to check the rs ingress. So kubectl get ingress, so you will be getting your ingress controller running. And once your ingress controller is running, so kubectl describe ingress app ingress. Okay, this is gonna be running, of course. Then if you wanna point the DNS to some IP, or this DNS just a device. If you wanna point the DNS name to some IP or DNS, okay, it's like if you wanna do it on your own device, that's fine. Don't worry about this. Then ingress ML we have, backend ML we have, frontend ML we have, and that is it. Good job. We have config map secrets, of course, just for the environment variables. We have volumes over here, and especially two types of volumes, empty dir and persistent volume. This is mainly for when two containers they want to talk to each other. At that time you will be using this. And persistent volume, when suppose I'm using database, I will have to use persistent volume anyway. So as I'm gonna be deploying the database, so at that time I have to create a persistent volume on AWS, so that if my database crashes, then I should be able to sync the data back from this persistent volume. So we'll definitely have to create it. So it turns out, yeah, there's a lot to do. That's true too, but let's continue working. Okay, so we have gone through almost everything, at least theoretically, and now let's start working on that. So this service will also be running on port 3000. I'm running it on port 3000. The question is that they are running on port 3000 on different nodes. As simple as that. Port 3000, that is right, but port 3000 of what? Port 3000 of a node, and the node of the front end, the node of the back end, they are gonna be the different ones. And what if they are the same? So will two services be able to run? I think this is the responsibility of what? This is the responsibility of I forgot the name, but there is something in Kubernetes that just simply assigns the right port to the right node. So it will be handled by that, if I'm not wrong. Okay, let me ask this thing from the chat GPT as well. Can two services be running on the same same port? Won't that be problematic? Suppose I have backend service, I have two cluster IPs, and both of them are running on port 80. So will it be okay? No. Let's see what's gonna happen. At least we should be just somehow be deploying it anyway today. Yes, it is completely fine. Two or many Kubernetes services can use the same port like AT without any problem. Why? This does not cause conflict. In Kubernetes, the service is not tied to a machine port globally. Each service gets its own cluster IP. Virtual IP address. That's right. A service gets its because that is why it becomes a fixed virtual IP. Its own DNS name. So even if both use port 80, so they will have different IP addresses. Got it? Even if they are using the same, but they will have different IP addresses. So different IP, same port, no conflict. That's right. I agree with that. I should agree with that anyway. Okay, then let's continue. So we have done this much. Apart from this particular thing, the backend is ready, front end is ready. Ingress, we haven't really done anything over here. So what I actually need to do, I need to create a config file that will sort of contain the, again, what are the uses of the config files. Config files mainly used for containing the environment variables. In this particular case, we are going to be storing the configuration of Nginx. Then that particular configuration will be passed to the Nginx Nginx controller, Nginx image that is running, so ultimately controller, container, yeah, so Nginx container, and hence Nginx container, ultimately running Nginx app, will be able to access that particular configuration and will be redirecting the request as per that. Too much, yeah. So what will I do? Nothing, copy paste. Where have I kept that? Come on. It turns out that not this one, yeah. Here it is. Okay, so I had it here. The front end is done, back end is done. DB manifest, we will be working on this. Reverse proxy manifest, this is the manual Nginx that we are creating. I will explain each and everything, but for now let me copy everything from here and let me paste. Again, this is not the right one. I will have to change many things. What are those things? I will be talking about them here. First of all, API version 1. I like to keep this this at the top. Kind is config map. API version v1. Metadata is gonna be Nginx config. Metadata Nginx config. That's fine. And then this is the key. This is the value. So ultimately, inside the data, I am saving this particular variable. Keep it like that. So this is the key, and the remaining are the variables. If you just use this pipe over here, so you will be able to keep many things one after the other, as simple as that. Okay, many commands ultimately, if I'm not wrong. Again, I mean, it does the same. Let me see what does the pipeline does not do. What does the pipe do here? I think it helped. Wow, I worked today and now my hands, they're hurt. Especially you should keep working hard. Otherwise, if you work hard someday, then your hands are gonna be hard. Okay, never mind. This actually ML concept. What does this ML? It's called literal block scaler. It means treat everything below as multi-line. Yeah, that's what I said. Treat everything as multi-line string exactly as it is. Preserve formatting specification in line. So it will just preserve everything, as simple as that. Coming back to this one, what am I saying here? I'm just simply saying that, okay, I'm gonna be Nginx. Load balancer will send the request over here. Okay, that's fine. So I'm gonna be getting the request on port 80. The request is gonna be coming where? The request is actually gonna be coming the front end. So this is gonna be to use front end. Coding the code dot side, this is fine. And once the request actually comes here, I have to forward the request to the front end. That's interesting. What was the name of the service? That was to front end service, if I'm not wrong, because I have to forward the request to the front end. So the name of the service was to do front end service. This is where I have to forward the request from there. So coming back to this one, that's fine. And the namespace, what is the namespace for the front end? So to do front end namespace, this is the namespace. So this is the service name, this is the namespace name, svc cluster local. By default I'm saying that okay, it will be running on port 3000. Later we'll be making it 80 as well, and that is it. The request will actually go to port 80. Now do I have to send? I am already sending the request to port 80 of the front end, and that is it. I should only be able to talk to my front end from the outside world. I shouldn't be able to talk to my backend. Having said that, I can even expose my backend directly. Completely up to me anyway. Exposing backend directly. Let's expose the backend to here just for the testing purpose. Later I will remove it. So I'm just simply exposing the backend so that for some reason if front end doesn't work, I should be able to talk to my backend using Postman. So to-do's backend namespace, that's actually the service name if I'm not wrong. So if I come here, to-do's backend not namespace, service actually. So am I crazy? To-do's backend, that's the name of the URL, right? Yeah, fine. To-do's backend.codingthecode.site, and this front end service should be to-do's backend service. Front end team should be to-do's backend namespace. Actually this is gonna be actually a namespace. So to-do's backend namespace svc cluster, it is also running on port 3000. That's fine, and that is it. So we have our config ready. That config had this key, and that key has this whole configuration. Okay, now it's time to use the configuration. We have created a config, but that doesn't mean we are using that. So I'm gonna be creating a deployment over here, Ngress. There should be only one replica of Nginx, and sort of an Ngress. It is sort of manual Ngress controller creation. Okay, it will be just simply handling the traffic, not sort of handling the traffic, rather, yeah, reverse proxying the traffic. Sort of, it will be getting the traffic, then sending it to the right service, as simple as that. Match label, Ingress app. It's okay, let it be here, this is fine. Container, Ingress, Nginx, ports 18, that's fine. Volume mounts, this is the important stuff here. First of all, what am I saying? I'm just simply saying that I'm gonna be creating a volume. Great job. This is gonna be the name of the volume. Again, great job. This volume will be using the Nginx config map. So this is the name of the Nginx config here. So this is the name that I'm using here. That's fine. And well, this name Nginx config. Let me give it a separate name so that it is easy to differentiate. Config, this has the name, config name has Nginx config, and then we created a volume. So volumes are gonna be Nginx config volume that we created, and over here I will have to specify the same volume. So volume mounts, like we are connecting the volume, mounting the volume ultimately. So in this particular image, pretty simple, this is the image that we are running. Ultimately a container is gonna be created. Volume, we are just simply mounting the volume. That simply means we created a volume. How volume got created? Volume got created using this config map that we had. Once it is done, then we are mounting the volume over here. Mounting in the sense the volume we have and the app that we have, we are just simply mounting them. Okay, what am I doing here? First of all, this is the volume that we are mounting. Great job. And mount path is gonna be etc nginx config. If you actually remember, and if you have ever worked with nginx, right? Yeah, nginx. So this is the file where you actually configure everything. So what am I doing? Mount path etc nginx config. So the volume that I have, that volume has nginx configuration, that will be mounted to this particular file. That simply means nginx config will have this whole configuration. As simple as that. I hope it does make sense. We'll check it. And subpath is nginx config. That simply means subpath should be replaced. Let me even talk to the AI regarding this. Does it mean nginx config will have the configuration mentioned in config map. Let's see. Yes, you are absolutely correct. So what your config is doing that step by step. First of all, you have the data. Okay, first of all, here I have defined the configuration. This means nginx config value, your full configuration. That's fine. This is actually a key, and nginx the name of the file should be nginx config, because this is the path where it will be mounted. So whatever values it has, so ultimately it has only one value nginx config, that will be mounted to that. Let's continue reading. Value is gonna be your full nginx config. That's fine. Value volume creation name is gonna be this. This Kubernetes takes that config map and makes it available as a volume file. That is right. Mounting into container, so mount etc and the subpath. So this is important part. It means take only the file nginx, this file, from config map and mount it as a file at this. So subpath is this. That simply means we only want this. So yes, subpath. Without subpath this would happen. Mount path will be etc nginx, then Kubernetes would mount entire directly like etc nginx file configure etc nginx other files. And okay, but with the subpath you are saying mount only this file, not the whole directly. Ultimately what we are saying that this is the file that we have, this is the key that we have, that gets converted as a file. And once we have the name, so I'm just simply saying that the subpath should be nginx config. Even if there are many other files and all, you don't really need to worry about that. Just simply mount this file to this particular thing, so it will be mounted to that. So whole information, so whatever I have here, again this comes from the config file, and that will be mounted to this. So whatever data I have here, that will be here as well. So this way the right configuration will be inside the nginx container, that is nginx app that is running. Pretty simple, no need to worry about anything. Then we have API. Again it doesn't have any namespace. To do that, let's give them the namespaces as well. So what I'm gonna do, just at the top, kind, I want a namespace. I don't even want to create a namespace because namespace is automatically created, but it's better to create that. I mean, even if you are recreating a namespace, that will not harm you. So to do jab namespace, this is, let me just simply copy it from here. In the backend I'm doing, and in the front end I'm doing the same, and in the ingress I'm gonna be doing the same. Or let me just simply write it, it doesn't really matter. So API version, that's gonna be v1 over here, and meta data, that will have name, and the name is gonna be to do app namespace. Pretty simple. Once this much is clear, done. So this config map is gonna have the same namespace. So namespace, that's because if I do not give them, they will have the default namespace, and that's what I don't want. So to do app namespace, again everything else is fine here. The deployment that I have, that will have the same namespace. So namespace to do app namespace, this is also done. And apart from this particular thing, okay, deployment has the same namespace. And then lastly we have the service, it will also have the namespace, to do app namespace. So we have done this, great job. So as this is done, we will not add the persistent volume to the storage, at least for now, to the database. We will directly be creating the database. We will make sure that it is working. Later we will add that thing as well. Okay, pretty simple. Coming back to DB right now, I don't really have anything, so I'll try to just simply copy paste if I can find, otherwise I'll have to write. Let's see if I can find here. So DB manifest, again I'll let you know exactly what am I doing here. One thing I did not explain here, that I missed, that is the, if I go to ingress, I'm actually using load balancer here. If you had if you see so API version, that's fine, let's keep it top. I like keeping the name, I mean kind at the top. API version, metadata, that's fine. Selector, on the basis of this selector, this particular service will be selecting. That's great. Protocol is TCP. Port is 80 because a load balancer, load balancer DNS will be created. Hence, that runs on port 80. Yeah, load balancer DNS will be created. That DNS will be getting the request on port 80. That is fine. And the target is the port 80. Now this is problematic here. Why? I'm saying target is port 80. Why? Because my Nginx app that is running on port 80. So if you see here properly, so Nginx app, this is actually running on port 80, so that's fine. And the type is the load balancer, so yeah, understandable. So what am I gonna do? This much is done. Let's go to this DB. This is the last thing that we have to configure. So database, it's gonna first of all have the same namespace. So let me, in case if I forget to create a namespace, because if you are applying the namespace again, if that is the same, so that will be just reconfigured, that's it, nothing will happen. So kind namespace API version, that's gonna be v1. So alrighty, came back online. So this particular thing is done as well. Containers, we have DB. This can actually be Postgres DB, just the name, that doesn't really matter. And we have Postgres latest. Interesting thing is that we need to have the Postgres password. I'm already mentioning that environment variable name is gonna be this, so that's fine, not really a big problem. So it will have this Postgres password, value Postgres 1234. Ports are gonna be 5432. This is the port that it's gonna be running on. Understandable. API version, and then this will be using cluster IP, because if you want one node to talk to another node, use cluster IP. If you want to expose the node to the outside world, you would use load balancer. This fine, this fine. Have I used namespace over here? Yeah, I have. Let me copy it, and I'm gonna be pasting it here as well. This is gonna be database or to-dos DB service. So to-dos database service, that's fine. To-dos Postgres DB. Okay, doesn't really matter. You can just name them anyway. In any format, that doesn't matter. I mean, if that makes sense, as long as that makes sense, that's fine. Interesting thing is this, that this service will be running on 5432. You can run on any port. You can run it on port 80 as well. It's completely up to you. You will have to just make sure that redirect it to the right IP address, and the job will be done. And target port is gonna be 5432 because my Postgres is running on 5432. This is the cluster IP. So congratulations, we've written everything. There's only one thing that is missing, and what is that? That is persistent volume. So if this database dies for some reason, your whole data is gone. So in that case, you will have to just simply create the persistent volume and all. We will be working on that, don't worry. But as for right now, this much is fine. Reverse proxy, EKS cluster. Of course, we have to create the EKS cluster as well. So this is gonna be used for that. And that is it. Congratulations, we've done it. Now we have to just simply run it. It will start running. But will it be right? The answer is no. Why? Ingress ML, that's fine. The thing is that, what do I have it here? I'm running, okay, this is fine. What am I running here? Backend, just the normal backend. Okay, no need to worry about it. HTTPD I'm running here. So what am I missing right now? There's one thing that is missing. When I'm running my front end, pretty simple. So this is the backend URL. These are the configure. I mean, these things I need to save somewhere, and then I need to get them from there, of course. So for this thing, it's better to use config map or secret. I mean, let's do one thing. In one place I'm gonna be using config map, in another place I'm gonna be using secret. Both are used. There's a different way to use them. In config I have to encrypt them. I have to convert them to the base64 format. I'll show you that. So first of all, this is the backend part. So let me do one thing. If I go to backend, I'm gonna be creating config map.ml if I'm not wrong. We need to have this configuration. Now, is this the best name or not? Let's see. So where did I cover this config related stuff? Over here. So this is where I have to go, and what should be config map.ml, that's fine. This is the overall configuration that you need to have. So I'm just simply gonna have it. By the way, that is not even needed. You can even it's better to create it on our own. So let's do that. So we need the API version, kind, metadata, backend config, namespace, default. You give it or not, up to you. And this, congratulations. Let's continue. So first of all, what do we want? We want to create config map API version. I should be getting some suggestions at least. API, not getting any suggestion. Version 1. Okay, metadata. That's insane. I mean, why am I not getting the suggestions? God knows. Metadata. What is gonna be the metadata of this? So this is gonna be config file. We already had a config file. Where? We had a config file in the ingress. So this is the config file that we had here. This one actually. So this is gonna be running every time. That's right. So how about keeping this config file inside the manifest only, so that you just apply it once and everything is done? That's not a bad idea actually. So instead of creating it or recreating it, how about once you created the namespace, create the config file here as well. Makes sense. Kind is gonna be, again, this will contain the environment variables, nothing else. So I want config map API version, that's actually gonna be v1, just v1, and metadata will have the name. Now what should be the name? What did I name it earlier in the English? The name was nginx config. Really? Service. I think this is the one. What should I name it? Ingress config. Ingress config. Okay, that's fine as well. Or it could, let it be the same, nginx config. That makes sense. Okay, coming back to this one. As for the name, this is the name config map of the backend. So to do backend config, as simple as that. And if that makes sense. Namespace, it should have a to-do app namespace, and it needs to have some data, of course. That's the most important part over here. And as for the data, how do we keep the data? We just keep the data like this. So can I do one thing? Can I go to the environment variable? Can I copy it and cut it and come back here? It is actually kept like this. Again, this is wrong anyway. So this should be, I'm gonna have port 4000 here. Then I will have allowed origin. Allowed origins are gonna be, now this is gonna be problematic. How? I will show you how. Even if I have the environment variables here, they are the wrong ones. Why wrong ones? Port 4000, that's okay. Allowed origins. Hopefully I'm allowing all the origins right now. Because if I have this origin over here, so from the service will the request will come here, right? That's right. So this is the service. Service is gonna send the request on port 3000. It will be using the localhost port 3000. Service uses localhost, right? It should be working, yeah. So if the service target port is port 3000, come on. So service will be sending the request to port 3000 target port, and that's gonna be sort of the local host. So if I'm making it like this, this is the backend. Port is gonna be this. Allowed origin. Come on. This is the request actually gonna come from the backend, the front end side. So whenever the request comes from the front end, I don't need to have it here, because only my front end will. Let me do one thing. Let me allow it all. I will dig deeper into it. Deeper into it. The thing is that my front end is in the same cluster, my backend is in the same cluster. So when I send the request from my, I'll dig deeper into it. It's no use thinking about this in advance. When everything's up and running, then we'll see how the overall flow looks like. And apart from this particular thing, this is something interesting. Why? Postgres, the password is actually Postgres1234. What is the host over here? Now the host of the database. First of all, we need to have the service name dot namespace name dot svc dot कुछ और होता है. Okay, let me see what am I missing. Can I duplicate it? Yeah, I have to just simply go here and there many times. How do we write the volumes? I forgot the way of writing the. I had it here already, if I'm not wrong. Yeah, I have it here already, so I don't need to go anywhere. Let's go somewhere here below. Where do I have it? Inside the ingress. So svc.cluster.local. Okay, got it. So where was I? Okay, here I was. So service name. What is the service name over here? In our case, that is to-dos db. What is the service name of the database? To-dos db service. Okay, fine. To-dos db service. What is the namespace for that? I have to check everything. Namespace. To-do app namespace. Namespace is same everywhere. That's fine. So namespace. To-do app namespace, and then svc dot cluster dot local and 5432. So this much will be just simply giving me the host, and then 5432 host in the sense the IP address and all. To-do db. That's fine. Okay, it's gonna be created inside that. And once this is done, there is one more thing. What is that? I'll have to migrate the data. Yeah. It's troublesome. Why it's troublesome? Because even if I have the database, I'll have to create the tables there separately. I feel like crying now. Look, this manifest will create the database. That's fine. Ultimately, a database is gonna be running, but that's gonna be empty database. There's gonna be no files, and I'll actually have to migrate the data. That's right. How will because I'm using Prisma over here, so migration needs to be done. So how can we do it? So we are gonna be running our backend. So whenever we run our backend, we have to make sure that migration actually happens. This is the Docker file that we have. We have to migrate it anyway. For migrating it, I need to know the IP. It will be started by the replica, deployment itself. What is the right way to migrate it? Because until unless I migrate this, nothing's gonna happen. So that's gonna be a problem here. So if my backend is using a database that is hosted in the cluster itself, and it is actually using Prisma, Postgres SQL ultimately. So now whenever I am running my backend, I need to make sure that backend, the schema needs to be migrated to the database, right? That is already inside the cluster. So what's the way? So that whenever backend container is running, at that time schema is actually migrated to the database automatically. This is crazy. Even if I'm migrating them. I need to have my Prisma over here. I hope here I'm getting the Prisma directly. Yeah, I am getting the Prisma. That Prisma already had the migrations, so that simply means it will not ask me for the name. So if I need to find a way through which whenever a container is created inside the cluster, ultimately that is running, it also migrates it to the database. And even before that, I'll have to make sure that my database is up and running. Crazy. Maybe yeah. Okay. This is very important, real problem, real world problem. You are thinking like a backend DevOps engineer now. Thank you. When backend starts, database schema must be migrated. The problem is you have backend Node.js plus Prisma, Postgres SQL inside the cluster requirement every time. Because if I were using different database, suppose Neon DB or something, so I could have migrated it there by default. But here that is inside. So every time backend starts, run Prisma migrate. Wrong approach, very common mistake. Okay, inside your Docker file, app starter, run npm run migrate and npm start. So correct. There are 3 good ways. Init container best for simple setups. Run migration before backend starts. Init containers. Name migrate your backend image. Okay, fine. Command npx prisma migrate deploy. Environment variable, this the environment variable of the database. So flow init container runs migrations, main backend starts. So backend only starts after migration succeeds. Simple automatic response. If multiple replicas, multiple migrations, Prisma usually handles safely, but it's still not ideal. Kubernetes job based Kubernetes practice. So job. Hey, turns out I'll have to run something new. Never expected this thing to face over here. So kind job metadata Prisma migrate template stack container migrate image is gonna be this this and this. It will have my backend image. It will take the database URL. It will use this particular script and will migrate. Restart policy never flow. Run job migration happens. Deployment backend deploy backend pods. Oh, makes sense. Slightly more setup. Okay, CI/CD pipeline in advance. Well, I haven't really discussed about. Gone through this particular thing yet. So kubectl apply in job migration. Wait for success. Deploy backend. Prisma specific command in place. I'm gonna go with this job option right now. So this thing. So ultimately, I have to create this job so that this actually. Or I can do one thing. Command can actually have normal commands as well. So this is my backend here, right? Come on, where is that? Here it is. And this is the image that is starting. So can't I do this thing that I will have command over here? Yeah, let me see. Can't I directly give the commands over here? And okay, and it will be using the environment variables. That's fine. It should be okay as well. Like what am I actually doing that? I have the environment variables over here. I will be just directly giving with the environment variables over here. I'll be giving the command as well. Hence that command will be running beforehand. Can't I give the environment variable and the commands just right here, so that whenever the container is created, those commands are gonna be running before the container creation, and hence the migration will happen. Tell me, I'm just simply guessing here. You are very close, but there's a small misunderstanding. Let's fix it clearly. Replicas did this. It should be replicas to. Now your actual question. What is the problem? Inside template I should have spec. What is so what am I supposed to be doing? Didn't I copy and paste the things I did? On the backend section I didn't. I have the same mistake everywhere. Come on. So I have specs and then I should have template actually just in here. Template and metadata. It will have template metadata, then it will have spec again. So I actually need to remove it. Excuse me. So that's my bad actually. That simply means if I made this mistake everywhere, I made it other places as well. So okay, this thing is done. So ultimately spec replication, this is selector template, this is the template, this is the spec container. So template spec containers, yeah, this is how it should be going on. Hence the same mistake should be here. Template, no, not really. Only in the backend section I had the mistake. Crazy. Here as well. Congratulations, template. This is actually gonna, let's remove it actually. And this part should be here. Alrighty, hopefully it is right. And now your actual question is, can I write the, no, that's not how it works. So what env does, this only sets environment variables, does it? No. Okay, so when do run the commands run via command this arguments or inside docker cmd. So but here's the important part, even if I run the command like this, so your image this, I'm gonna be just simply running the command. So npx prisma migrate deploy and node server.js, it will run migration, we start the server. That's right. Problem, you have two replicas, so both pods will run migration at the same time. This can cause issues, race conditions, db logs. Yeah, that's right. So what you are trying to describe, you said run before container. This is exactly what init containers are for. So init containers, that simply means we have to have this. Amazing job, good learning actually. So init containers migration will have this. Congratulations, you are doomed. So we have to go through this particular part here. So let me just simply copy it for now, and I'm gonna be just simply pasting it. So inside the containers, not even containers, inside this spec. Okay, I mean, seems to be fine. Name is gonna be migrate, unstoppable the coder to do's backend, npx prisma migrate. Now I'm using bun prisma migrate and dev. That's the command. But prisma migrate dev. Yeah. And database URL PostgreSDB. Now what is the address of the database? 5432 to-dos, it should be to-dos db, that's fine. And Postgres, it should be Postgres 1234 @ now host. I think this is the host. Should be getting some suggestions here, this one. So what have I written here? Let me have a quick look here. So Postgres, this is the username, password, and this is the host. So to-dos db service, and namespace svc cluster local 5432. And have I written it twice? To-dos, yeah, this thing is not needed. This makes sense. Probably I need to remove this as well. So okay, ultimately it will run beforehand. Hopefully it will run, and then this particular container is gonna be created, and that's it, the job will be done. Great job, we fixed this. And but still you have to replica problem runs. So pod 1 runs migration, pod 2 runs migration again. Best practice. Use Kubernetes. Allah. Okay. Use a Kubernetes job. Run migration only once. So job runs db migration deploy backend. So ultimately it is asking me to create a job, and that job will be responsible for running the container. And when it comes to the job, so this is how the job is created. Now we have to tackle two things here. First one is the job. Let me just simply copy the because of course it cannot be done right here. So what are the to-dos here? To-dos are really interesting. The first to-do is this, that we have to know about the job, how this job thing works. I've never tried this. Try this one. Ultimately the best approach is gonna be only this. And as for right now, what I have, init containers we have here, and again the code is gonna be this. We have to ultimately check both the things. Just a minute. So let me copy it from here. Come on, from there. I'm actually gonna copy all these things from here, so that at least I have just an example. Again, I made a lot of changes. I'm gonna be back after a break and then continue from here on. And let me paste it over here. These are the few things that I came to know. So we are gonna be going through them. Until then, take care, bye bye, and I'm gonna be catching up soon, probably in half an hour or something. Until then, bye bye.